Okay, good afternoon. Let's do some mic testing. Those at the back, can you hear me? Those at the back, okay. Those at the back, can you see the code? Can you see the code? If no, please move forward. Okay, let's start. Good afternoon, everybody. We are going to talk about function abstraction. Okay, can we have some silence, please? So we are going to cover function abstractions for 3 weeks. This is the second week. I think we started it last week. So we'll cover this again, and then next week we'll cover part of it again, because this is the most important concept in programming language. So just a recap. Function is like a black box. So you put something inside, and then you chunk it out something for you, right? So when you write a function, you know what is exactly what it's doing inside the functions. But when someone writes a function and you use their function, actually you don't know what's happening inside. You just know that what is expected as output when you provide the inputs, right? So that's the beauty of functions. We call this abstraction because you abstract away the details so that you don't have to go to the detail. Okay, so for example, cosine, you put in 0, they'll give you 1. You don't have to know how cosine is being computed. That's not important to you. You just want to use this facility, this ability, or this facility of cosine. Right, I think we covered that already last week. So this is how you write a function, right? You define a function in your script, in your Python script, right? So you start with a keyword called def, and then you have this is the name of the function, because these are the things that you communicate with other people, right? And these are the arguments, input arguments, or it's called arguments, or it's called parameters. There are many names for it. Okay? And this is an indentation. That's very important. Without indentation, the function does not work. That's a feature of Python, right? Okay? And then this is the output. Why is this the output? Why x times x is the output to this function, from this function? The reason is basically because of this word. Return is the most important part in a function definition. It's a keyword. It says that this function is a function because when you give him some input, it provides some output. That's the name of a function. Mathematically, when you talk about function, you know what it is. You give him some input, they provide some output. And return is the most important thing there to ensure that this function provides some output for you to use. Okay? But in programming language like in Python, the word function or this definition, or I call it a function, did not have a return. We'll see that later on. That's a weird thing about programming language. You write a function, it's not really a function, right? Because you can give input, you can sometimes don't even give input, and it may not provide output. Output in the sense it did not return some value to you. Okay? So with this, you can start running programs, right? So you know this thing. I take this square, I put in the 3 inside. It computes x times x, 3 times 3 gets 9, and it returns you 9. Okay? And because of this return, it gives you 9 as a result of this call. Right? Return from the call, they give you a value. And you can use the value for other purpose. That's what function is about. Okay? You can do this. This is called nested call, right? You can have square there, and then inside the argument for the square is yet another function. And this function is the same function. It takes 2 as the argument. So you know that 2 times 2 is square of 2, you get 4. Right? And then square of 4, you get 16. So you see here, return is very important. With the word returns, this square of 2 will return you 4. Right? It will return you 4 as a result of your calling. You call this function, it returns you 4. You call the function with the argument 2, it returns you 4. And then with this 4 becomes an argument to this square, to the bigger outer square. And with the 4 as the input, it returns you 16. Right? So return is a very important thing here. It allows you to communicate, to get the value. You pass something to the function, you expect to get something back from the function. And with that something that you obtain, you can do something else. That is a very important part of it. Okay? What about square 3 or 4? This says that this function takes 2 arguments. What will happen to that? It cannot run, right? Why? Because square only expects 1 argument. You are providing 2 arguments, 3 and 4. So we call this the function, the call, and the function definition. It does not match. Right? The function definition says that I expect 1 argument, but the call provides 2 arguments. So the function doesn't know what to do. Make sense? So this will not work. So that's a quick revision. And today what we want to cover is basically a lot of topics. We talk about function. We talk about parameters. That means arguments. Different ways of passing arguments. We talk about return values. I think there's some confusion about return and print function. Some tutor mentioned that. Right, so we'll look into that slightly more detail. We look at the mechanism behind how function is called. Okay? And we introduce something called a call stack. A stack. And we tell you what is a stack. And then we go into a deeper one, what is called recursion. Recursion is always exciting topics, especially for CS1010E in whatever language. Right? People look at the word recursion, you get scared. But recursion is a beautiful thing. Try to appreciate it and enjoy it. And then lastly, we cover something called the variable scope. Right? There is something also, you have learned this already. We just try to formalize it. Okay? So first thing is parameter. Let me set up my computer. I just restarted it because there's some problem. Okay, parameter of functions. So let's look at this function. This is add two things. You want to add two things together. So you expect to have two things as an input, A and B, right? Separated by a comma. And what does it do? It's a very simple thing, A plus B. Right? They just add them together. Okay, so with that, we can do, if I say add of 1 and 2, you get 2. You get 3, right? 1 plus 2 is 3. You get add of 1, then you get error, right? Because this function expects two inputs, but you only provide one input. Okay? This says that I'm calling this function with no input. Then, of course, it's not correct because the function expects two inputs. And this one, of course, is wrong, right? All these are wrong because there's a mismatch in the number of arguments that you provide. That's wrong. Okay? So in Python, parameters has no declared types. We can pass any kind of variables to the functions. Right? So when I write this thing, I can write I can pass two arguments. These are two real numbers, or we call it the floating point numbers, and I can add it up properly. There's no problem. I can even do this, right? Because the plus operators can be interpreted in many ways, right? So in this way, it will be a concatenation of two strings. So you get the result as that. Make sense? So this function, what is the type of this function? What input does it take? It depends. It can be quite varied. Of course, it has to be correct. Okay? So and you can do these things also. The reason why true and true, you can add them up. The reason is because of the addition. When you see the addition, the system will know that you need to take two values. And these two values can be real number, can be integer, can be string. Right? And in this case, true and true can be converted into 1, so you add them up. So the system is smart enough to know all these things. Okay? So as far as it works, it's okay. So what happens if I say add two string? If I say this thing, right? Just a second. Okay, so I have this program here. If I add two things, right? What happens if I do this? I know that I can do this, right? 1 plus 2, right? Can I do these things? 1, A, B, C. Is it possible to do that? Not possible, right? No, they'll tell you errors. Okay, because 1 and 2, 1 and a string, the integer and string cannot be added together. Make sense? Okay. Next thing is come to an important part, important programming concept. This one is not just applied to Python, it applies to all the languages. In fact, all the topics that we cover today apply to all languages, not just Python. Okay? So for example, a pass by values. Okay? I define a function called change value. I define a function called change values. Okay? And this change value takes the argument n. And what it does is assign 999 to n. And then print out the n. Okay? Firstly, you look at this function. Is there a return statement? There's no return statement inside the function, right? So this function does not return anything. What does it do? It prints something on the screen, right? On the console. Make sense? It does not return anything to the caller. Okay? But it prints something on the console. What is the console? What is the console? This one is console, right? The shell is a console. Whatever you interact with the system, it printed out there. So this function on the right-hand side, the function print, it prints something on this console. Okay? So I can do these things, right? I can say change value, right? 3, right? Print out something. Make sense? Why does it print out 999? Because I set n to 999, right? And then I print out the value. Make sense? Okay? So this example here, I say that x is equals to 0. Okay? And then I say change value x. Okay? And you find that the result is 999 because it goes through the function says print 999. Okay? My question is, does x change? Does x change? Because when I make this call, I pass the value of x to the function called change value, right? And this value can attach to n. N becomes 999. Does x change? No, the answer is no good, right? So x does not change, it's still 0. Okay? X does not change, it's still 0. So what this idea is called the pass by value ideas. Okay? So let's go through this. Okay? What is pass by value? Here is what I'm showing you. You can imagine that every function that you define is a country, is a town, whatever. Yes, war, build out all these things, protect itself. Every function that you define. So the function here, this function, is a function. You can think of it as a cursor. Okay? This cursor can interact with outside through what? Through the parameter or through the argument, n. So I put the n here. Okay? Make sense? This one is the environment. This environment is the screen here, the script there. Right? Over there, I set x is equal to 0. Okay? So in this, you can think of this environment is a big cursor. Okay? And it has a 0 there. You set x to be 0. And now I call this function. From here, I call these things. Right? I say change value. I call change value and say that I pass you the value of x. Right? X is 0. I pass you the value of x. I want to pass it over. So this will go over to the other side. N will accept 0 as a value. And n will start processing. So now n is 999. Print out n is print out 999. Okay? And then finish is stop there. Okay? If you look at the environment here, the other cursor, what is the value of x? Still 0. This is called pass by value. Okay? You take the value of x, you pass it over. You don't pass x over, okay? You're just a messenger. You pass the message over, that's all. Okay? Make sense? So x does not change, still remain the same. No change to value of x after calling. This is called pass by value because I'm passing a value over. Okay? Suppose I change my program. This is my program now. Define change value. Right? I define a new function called change value, but now the parameter is called x. Okay? The parameter is called x. This parameter looks the same as this x here. Both are variables. Correct? Okay? So this is a cursor. This cursor has an interface. That interface is called x. This x and this x are different x. Okay? Because this is in one cursor, one region, this is another region. They are not the same x. So when I call these things, so here I say x equals 0, I change value x, I'm going to pass 0 over to that place. Okay? And this x receive this cursor, change value, receive x. And you change x to 999, right? And then you print out x. So as a result, what does it print out? 999. Okay? Does it change the x here? It doesn't change. Does it make sense? This is a very important concept here. Okay? This is a concept, the whole concept of a function is this. It protects itself very firmly. Right? It defines some parameters, some arguments, so that it can interface with the world outside. Okay? But nobody can touch its own parameter. It decides what to do with this parameter. Other people cannot touch. And I cannot touch other people's parameter also. This is a very, very beautiful concept in programming language. Okay, so no change to x over here after calling the change value x. So it's very important to have these things. This is a very essential concept. Okay, so for parameters that are primitive, what is primitive? Primitive are data like integer, like floats, like Boolean, all these things. Okay, these parameters are passed by value. Just like just now the one, when I say x is equal to 0, I call function change value with x. The value of x, because it's integer, you'll pass over. X will not change. Right? X itself, in that region, in that cursor, it doesn't change. Okay? But it's not always the case. It's not the case for some parameters, like sequences or this thing. And we'll talk about that, I think, maybe somewhere in the middle of the week or the semester, we'll talk about these things. But currently, you know, if it's integer, it's Boolean, it's float, these are primitive. Primitive means this is the simplest representation of value or data in computer. It's primitive. And those things, they pass by value. And you know what is a pass by value now? You build cursor. Okay? Good. Now, just announcement. Take a break. We have put up the training one in cosmology. You can try and do some training yourself. If you want to write some code there, try to understand whether your concept is right or not, you can go to the training one in cosmology and try it out. There's no mark. Okay? We have no time to mark your training also. So there's no marks attached to it, but we encourage you to try it out. Okay? By now, this is week 3 already. You should have set up your Python. If you have not set up Python, then please hurry up, set up Python. Put up your question into the cosmology forum page. Get someone to answer your question. You should have finished your assignment 1 in cosmology last week, and assignment 2 is out again. And this assignment 2 is 1 week or so, right? You should have a tutorial grouping already. You know which group you belong to. If you still have a problem, please ask the head TA, Mr. Sunima. If you don't know who that is, write an email to me. I'll forward your email to him. Okay? And you should have completed tutorial 1 tutorial section already. And please go to the right tutorial group. Please go to the right tutorial group. Okay? And then there is such a thing called remedial. It's additional help that we offer to you. It's free of charge. It's optional to you. We will put up a several session, maybe 2 sessions, right? Sometimes on Thursday, Friday. And if you have problems, you can just come to this remedial session and ask questions. Either the TA or the lecturer will be there to help you solve some of the problems. Okay? We don't expect 900 people to go into the place. So we book a small room to cater for maybe 100 students, right, for the remedial session. So you are encouraged to go for that if you still have doubts with the programming. Okay? So don't get too frustrated with programming. Sometimes it can get quite frustrated, but it should be fun. Okay, we talk about parameters. Now we want to talk about return value. I told you return value is very important. And there's another thing that is called a print. And some people get confused what are the difference between the two things. It's okay, I just put 2 slides like that. I put just 1 slide there, you can read, right? Okay? Okay, so print versus return. Okay? So I have these 2 functions here, full print. Look at the function, right? This full print, it takes no argument. It does not take any arguments. But the bracket is important. Bracket say that it's a function. Without a bracket, it's not a function. Okay? So when you call this function, you have to still put a bracket there because it's a function. Okay? And then what does it do? It prints 3 2 times. It prints 3 2 times. Okay? Look at the second one. Full return. So this is another function. It doesn't take any arguments. What does it do? It returns 3 2 times. Okay? And now I run this program. I get these things. Right? So on the right-hand side, this part is my script. It's my shell. It's my shell or my console. Right? When you see this triple arrow, it is a console. Console is just like these things here. This is a console. Anything that you communicate with a computer, the result print out here. So this is called console. So you can think of this as a mini console. Anything that you communicate with Python system, they print out the result on this console, on these things here. Okay? So this one, it returns one, it only returns 1 3. What's the difference between the two? Okay? So you look at this question for this simple one. I return 3, return 3. What's wrong with this? Can I return 3 2 times? Is it okay to return 3 2 times? No, that's nothing to do with arguments. Okay? Return tells a function that this is the end of the function. When you see a return, you say, when your execution reaches a particular point, return here, it tells the system that I want to get out from this function. I no longer want to execute anymore. I compute what is the value here, arguments here for the return. I get the value, I return it to the caller. Okay, that's what return is doing. So this line return 3, it already returned to the function, out of the function after return. So you will never execute this line. This line will never get executed. So this return can be there. It's redundant. It can never get used. Make sense? Whenever you see a return, you know that that's the end of my function execution. I want to get out. So return is that. Print is different. Print basically says that I want to print something on the console. That's all. It's not the end of my program, whatever. I just want to print something on the console. Make sense? Okay? So you have to distinguish between these two. You can have 2 prints because I just want to print as many things as I want. That's fine. But you can have only 1 return here because the second return is useless. Okay, you can put 300 here. It still return 3. Make sense? Okay? Now let's look at this part. Okay, so return will end the function immediately. That's what it means. Okay, so I can write in this. Let me write in this way now, a simple one. Okay, I just have 1 print here and 1 return here. Okay, so both codes are correct. The first code, they print out something. Does it return anything? The first code. Does it return anything? It does not. Remember, because there's no return statement, it does not return anything. Does it print something? Yes. Okay, make sense? Second one, print, full underscore return 3. Does it return anything? Yes, return the 3. Does it print anything? No, it does not print anything. Make sense? Okay? Simple thing, right? It doesn't print anything. Because that's my function. I tell my function that just return 3. Don't do any other things. So return 3. That's the understanding of this function. So when you do this, now I'm in the console, right? I'm in the console. I run this thing. It tells me that 3. It prints a 3 on the console. Make sense? Full print. It prints a 3 on the console. Makes sense, right? And what about this one? It also print a 3 on the console. Why is that so? Why does it print something out? Why does it print something out? That's because of this console. Okay? It's because of this console, not because of this function. This function does not print anything. This function only returns a 3. But the way the console, this console, this one, the way it works is that if the last thing you do is to return a value, I print out the value for you to see. That's what this console is doing. If the last thing you return to me After you execute the function, has a value, I return this value to you. I print out the value for you to see. Okay? So that's the effort of the console. So let's look at this one. How do I know there are difference? Wow, I do this thing. X is equals to full print 3. Okay? I do this thing. X equals to 2. I do an assignment. I call this function, and then I assign the value to X. Okay? And I got a 3 here. Why? Because full print a 3. Right? Full 3, print 3, print a 3. So that's fine, right? So it print out the 3, and then it performed the assignment. It's assigned some value to X. Make sense? What about this one? Full return. It returns 3. Correct or not? It returns a 3. Where does it go to? This 3 is assigned to Y. Make sense? Throughout the whole process, I never call prints. So they never print anything. Make sense? Okay? So where is the 3? I return the 3. Where is it? It's in Y. Yes, it's in Y. Makes sense, right? So now Y has a 3. Okay, let's look at this one again. So I'll do these things. Where is it? I have a print here, right? So I do this thing. X is equals to print full print 3, okay? Right? Remember my full here, I print 3 2 times. So it should print out 3 2 times for me. So I enter here, it print out 3 2 times for me. Okay? And then it said the result is sent to X. So I ask, what is X? X has nothing. X has nothing. Make sense? Because I did not return anything from full print, I did not return anything to the caller. Right? This thing is calling, this whole thing is calling full print. And full print doesn't return anything. So there's nothing returned as a result of calling the function. So nothing assigned to X. Okay? X is called none. Okay? If I ask, what is the value of X? Nothing. And there's a way to represent nothing, and that's called none. None means nothing. Okay? So I check, is X none? He said yes, because X contains nothing. Okay? So if I do this one, Y is return 3. Okay? So now, this return function does not print anything. So it doesn't print anything out. Right? It returns a value. Right? It returns a value. Where does it go to? It goes to Y. So it also does not print out any return value out for you to see. Okay? So now when I ask Y, it says 3. You see? This is confusing because of this thing, because of this shell or this console. It makes it quite confusing, but it also makes it quite useful. So don't get confused by that. Okay? Print means print on the console. Return means what? You return a value to the caller. Whoever is calling it, you return it to him. Right? In the process, you don't have to print anything. Unless the function call is the last thing you do in the console. Console will say that nobody is accepting this caller. When you're calling this function, nobody is accepting the result. So you print out the result on the console. That's all. Okay? The art of nothingness. Okay. So that's all for this, I think. So I mentioned this is actually the echo. Right? When you return, nobody is accepting this return value. You echo it onto the screen to let you see that, hey, there's a result returned. That's all. No big deal. Okay? So I'll skip these things. So you know these things, right? When I call a function 0, cosine 0, it returns 1. Right? And where does it go to? It goes to X. So now X is 1. X contains 1. So assignment is important. And this function call is usually used before on the right side of the assignment statement. This is called assignment statement. This is called the assignment operators. On the right side, you normally have a function call, and the result is captured by a variables. That is usually what you do. Okay? Full print, you don't have anything. That's fine. Okay? So there's a name actually for this. In general, we call all these functions, right? But for function that returns nothing, like this function, It returns nothing. There's actually a formal name for it. It's called a procedure. In the old languages, they distinguish very clearly what is a procedure, what is a function. A function is something that always returns something to you. A procedure is something that it prints something. It's a function that it prints something and never returns anything. So it becomes very clear. But now people drop this word called procedure. Everybody use function. Okay, so there's a little bit confusion there. Okay? All functions always return something. Whenever you call a function, it always returns something, right? This one will return integer 3, full return 3. This one, it does not return anything because there is no return statement, so it returns none. Remember, I tell you, right? None is nothing. So it returns none. You normally don't use none. Okay? Okay, let's skip this one. Okay, let's try archipelago. Oh, let me try. Let me set the computer first. Huh? Just now my computer crashed, so. Okay, can you try this? I hope you can. You know how to get in, right? Not many people go in. Why? Is archaeology so boring? This question. Can you try and give me the answer? So I define a function called foo, takes two arguments, right? And they perform these things. And I call this, I call the function foo, and then when the result is returned, I get the value x. Oh. How do I show the whole thing? So this is a function. Which answer is correct? Let me show you the question again. Okay? What should be the value of x at the end of this function, this assignment statement? Anybody has any answer? Can you go in? Okay, only one person. 3%. What else? 5%. There are too many arguments in the definition. Number 2. Wow, 7. Okay. Any others? Okay, let's look at this question quickly. 6 and 8. So x is 6, y is 8. You go through it. X is 6 is greater than y. 8 plus 3? No, that's not true. I come to here. Else if, right? 6 is less than 8 minus 3. 8 minus 3 is 5. 6 is less than 5? No. So I come to here, right? Agree? I come to here. And here you say print this value. 6 plus 8 divided by 2, I get 7. Make sense? Right? So you print out the value 7. What does it return? What does it return? It returns nothing, right? This is the last statement you execute. There's no return. Right? So when I have these things, what does this return? Nothing. So you assign to x, so x is nothing. Make sense? Okay? Okay, we go to the next topics. Calling other functions. You already know how to call other functions. So this is one example here. Right? I have many functions. I know that a function inside the body of the function, I can call another function. So this function, hypotenuse, it takes into argument, it calls two functions. One is square root, the other one is sum of square. Right? What is sum of square? Sum of square is defined here. Square of x plus square of y. What is square is defined here. Right? So now I call these things. So this one here, when I do this way, okay, I know that in order to find what is the hypotenuse of A and B, what I need to do is just find what is sum of square, right? And then I find what is square x and square y, and I get the answer, and then you go back. Right? As opposed to this way, this is also a right way to write the program, right? The only difference is that this one, you're assuming that someone understands what is this hypotenuse when you look at this code. This one is very clear. It tells you basically the logic behind how do you compute hypotenuse. Okay? Both are equally correct, but what I want to show is this particular case. This one shows that you can break down your program into smaller pieces and piece them together using function. That's the power of function as an abstraction, right? Later on, I said that I want to change the way I compute square. I want to do it some other way, right? Some other way to compute square. I just come here and change this thing. I don't have to change this one. I don't have to change this one. They are all the same. I just change here, right? But this one, I have to come to a hypotenuse and change it, right? Because the way I compute square is different. Suppose this square is used by many functions. It's used by many functions. Everybody, a lot of functions call square. Then by changing this thing, I can change all the functions, how they compute square. But if you write in this way, you want to change this square, you have to go to all functions and see whether they use square or not. Right? Okay? So this is a good thing about functions, making a lot of calls, calling other functions. Okay? So I can visualize these things. We use a call tree to visualize it. Call trees. So for example, here I'm calling this thing hypotenuse 3 and 4. So I'm making a call. When I make this call, what happened? This call, the definition is invoked. We say it's invoked. It's called. It's being called. And what does it do? You do the job. You does the job. The job is to perform these things, right? Correct? To perform these things. And to perform this thing, what is the first thing it has to do? Is it square, or is it square root, or is it sum of square? Which one should you do first? Sum of square, right? Because that's the argument to a function's square root. Square root, right? You know, I keep saying square. Square root, right? Okay, sum of square is the argument. The result of sum of square is the argument to the square root. So I should compute the argument first, right? So the first thing I do is I compute this. So this hypotenuse, it calls sum of square. Okay? It calls sum of square. And then what does sum of square do? You look at the code here, right? It calls square, right? Square x plus square y. Which one does it do first? Square x. Why? Arithmetic always, addition operation, you always do the left-hand side first. That's the rule of the computer. Okay? So you do this first, square 3 first. Right? What is square 3? Square 3 is here. You get 9, right? So you call this function, you get 9, you return 9. So you have completed this one. Right? Completed part of it. So this call has 2 squares. It makes 2 squares, call to 2 squares. So now it calls the second one. Right? Square of 4. And square of 4 is 4 times 4. You get 16. You get the result. Now you perform addition. Right? Add up. You get 25. Right? And this is what? This is hypotenuse, this thing, right? And now it's called square root. By passing 25 into it, and this one give you 5, and now you return values. Correct? This is called a call trees. A call trees describe what happened to the whole program when you run this program, what happened to all the calls. Who calls who? That's what it says. Huh? So we normally have a name for it. When this one is calling this, when this one is calling this one is called the caller, this one is called the callee. That's all. Caller, callee. Right? And when this guy is calling this guy, then this guy is called the caller, this guy is called the callee. Okay? And this call tree shows you the dynamic of the whole calls, all the function calls inside, when they try to execute your program. Callee is not the argument. Callee is the function that you call. Right? Sum of square is calling this thing. So this sum of square is caller, square x is callee. Because I'm calling square of x, so square of x is callee, I'm the caller, I call him. Okay? Just a terminology. Okay, the call stack tells you the calling sequence. So from that figure, you know that calling sequence, I call this first, then I call this, then I call this, right? When I'm calling this, do I get the result for this already? Not yet, right? I only get the result from here after I make a call for this, right? When I call this, do I get the result for this? Not yet, right? Because in order to get the result of this, I need to call this one first, right? So this is called a nested call, right? I call one by one. When I'm calling this one, I don't have a result for this yet. I do not have the result for this yet. Okay? So this is called a call stack. Okay? So firstly, what is a stack? A stack is called a first in, last out order. A stack is a very important concept in computer science, right? And it's a very simple concept also. You'll use it if you go to the advanced course in computer science. The second course in computer science, you'll learn this. Basically, a stack means that it's first in, last out. That means you keep stacking, right? The first one to go in will be the last one to come out. Make sense? So this is how you do it. We call this a push. You keep pushing things into the stack. And the first one you push in is already in the bottom of the stack. You cannot take it out. Right? And then when you take it out, it's called pop. You keep popping one by one. Okay, that's called pop. So we call it a philo or LIFO. I normally call it LIFO. First in, last out. Okay, or last in, first out. Up to you. Right? So that's a stack. So we want to learn about stack. So let's look at this program. Okay, this program, I have 3 functions. P1, in P1 you call P2, P2 call P3, right? P3 call P3 actually do a square, right? X times X. And you get a result and put inside the output, and then you print out the outputs. And no, you return the outputs. It doesn't print out, you return the outputs. Return to the caller, the one who called it, right? So I have this statement here. This basically says I'm calling P1 with argument 3. So according to these things, if you run it, that's the result that you get, right? You can read this, when you have time. Okay, let me show you how it works. So I want to call the function P1 with argument 3, right? So this is my main thing. This is the caller. This caller is calling P1. So P1 is a callee. So P1 starts to get executed. And what it does is that in order for it to execute, of course, you print out a statement, right? And then you execute P of 2. So you call P2. Because in order to get the result, you need to get what is the result of P2 first. So P2 with X equals to 3. So you look at this, look at here, right? This considers a stack. So the first thing, the call is P1. P1 of 3 is inside there already. And P1 of 3 call P2 of 3. So P2 of 3 is on top of P1 of 3. Right? And you go to P2, you want to execute P2, you have P3 of X. So you call P3 of X. Right? You get X, and then you call here. So now I'm calling P3 here. When I'm calling P3 of 3, when I'm trying to find what is the value of P3 of 3, I do not know what is the value for P2. I do not know what is the value for P1. They are waiting there. That's why they are in the stack. Okay? And now I got a value for P3 of 3. the value is 9, right? The value is 9. And then it returns value. It returns this output, 9, to who? To whoever is calling. P2 is calling P3. So it returned it. So it returned here, and this 9 is recorded in output. At this time, this one is gone. I've done with this, right? P3 is gone. Okay? Now I have this answer, so I have this output is 9. So what does it do in P2? It returns the output. It returns 9. So P2 return 9 to whom? Whoever is calling P2, which is here, right? And again, this one is gone. Right? Because I've completed the call. And what is left behind is P1. P1, what does P1 do? It get a value 9 from P2, right? And then it returns this value 9. So it returns 9. It's already written there. It's 9 here. It returns 9. Does it make sense? So this is a call stack. It grows. When you make a call, call another call, call another call, call another call, it grows. Okay? Question on this? Let's look at these questions on the, maybe not, sorry, not yet. Okay. Just now we talked about calling function. A call B, P1 call P2, P2 call P3. The question is, can I call myself? Can I call myself? This gets very interesting. Okay? And this is called recursion. It's a very important concept. Right? This one is recursion because you are looking yourself. You're looking at yourself. Right, that is recursion. Recursion is a very central idea in CS, right? And there are many examples of recursion, if you can spot them, right? This one is advertisement, right? This one is just advertisement. This is a triangle within a triangle. And this one, I think one of the assignments you are going to do this thing. You use recursion to create a tree, right? If you look at every small tree here, they are the same as a big tree. It's just a smaller version of big tree, that's all. And this one is Garfield dreaming, recursively. Okay? Recursion is a function that calls itself. Okay? It's a paradigm of solving a big problem by solving a smaller version of the same problem. We call it a mini-me. Okay? It's an important concept because it really captures the idea of divide and conquer. You know what is divide and conquer, right? You have a big problem, how do you solve it? Divide the small part and solve it, right? Okay, that's divide and conquer. And this one uses divide and conquer by creating a small mini you to solve all these problems. And that's a beautiful part of it. Okay, recursion is very useful. You know what is this thing? Inception, right? What is Inception? Do you see watch a movie before, Inception? What does it do? It goes into someone's dream, right? Right? It goes in someone's dream and then it works on someone's dream. And if it cannot solve the problem, what does it do? It goes to someone's dreams, right? You keep going in. The more you go in, the more you can change something more important, right? Or more detrimental to the person, right? Okay? This idea of recursion. This idea of recursion. Why is it idea of recursion? Because when you go to that someone's dream, do you know the show or not? Actually, I didn't watch the show. You want to go to someone's dream, you go in again, how do you get out? Suppose I'm in level 1, I go to level 2. I go into level 3, how do I get out? I go back to level 2, then I go back to level 1, right? You go in this way, you come out this way. That's recursion. Okay? This is a small little tiny program, right? It says dream. You're in level 1, okay? And then you run it. This one is of course not Inception. Huh? Okay, so this one what it does is that you call dream, right? Is it called dream? Yes. I say level 1. Then you say enter dream level 1, enter dream level 2. You keep going down until level 3. You say get out. How do you get out? You wake up, right? When you wake up in level 3, from level 3 you're in level 2. Because just now you came from level 2. right? And wake up from level 2, you go to level 1. That's what it's doing. Right? That's what inception is doing. Okay? That's the result that you can see. Okay? So that's inception. And this is a very nice quote here. I like this quote. To iterate is human, to recurse is divine. Okay? Think about that. Because recursion is really beautiful in that sense. It gives you a very neat solution. We'll show you a neat solution next week, not this week. This week we'll show you all the boring things about recursion. Okay? So factorial function, let's look at factorial function. You know what is factorial function, right? N factorial, 1 up to n, 1 times 2 times 3 times 4. I think you do that before, right? How do you write a factorial function? Right? That's how you write it, right? Last week, if you use iteration, you learn this thing, right? Answer is 1. That's the answer you want to collect. Start with 1. I start with 1, right? And then I will increase up to n, right? And every time when you increase I becomes 1, 2, 3, 4, 5. Every time you get an answer, you multiply it to the answer. So answer is accumulating the answer, right? By starting with 1, then you accumulate, then times 2, times 3, times 4, times 5, times 5, times 6, right? And every time, in this loop here, you always increment I by 1. Right? Until you hit n, then you get out. And the result is this thing. Right? This is not a very good, there is not a very good program, function, definition, because you use print. It should be returned. Okay? But that's small matter. Okay? That's iteration. You learned this before. Okay? How do you write it recursively? Right? So this is what people normally feel. If you give me a solution that is so complex, I say I don't want to know what it is because it's so complex. But if you can write in a mathematical format beautifully, then I will accept it. So this is a definition of a factorial. Okay? It says that when n is equal to 1, 1 factorial is 1. Simple. When n is equal to not 1, it's not 1 bigger than 1, what do? You find what is the factorial of n minus 1. Then it times n. So when you have 3 factorial, what do? You find what is 2 factorial, and then times 3. Right? And that will be the result for the factorial. So this answer is very clean, very elegant. And that's why it's beautiful about it. Okay? So you want to find what is factorial for 5. You just do 4 factorial, right, times 3. What is 4 factorial? Well, 4 factorial is 3 factorial times 4. What is 3 factorial? 3 factorial is 2 factorial times 1 times 3. What is 2 factorial? 1 factorial times 2. What is 1 factorial? 1. Right? Oh, 0. Here is 0. So 1 factorial is 0 factorial times 1. What is 0 factorial? 1. Then you stop there. And then everything multiplied together, you get the answer. Okay? So this is a code. Surprisingly, it's so simple. You look at this code, okay, you look at this mathematical equation, they are the same. Right? This thing, the bank here, the exclamation mark is factorial. That's all. They look exactly the same. If n is, sorry, I write wrongly. If n is equal to 0, then it's 1. It should be 1 here. Otherwise, n minus 1 factorial, I'm calling myself, right, times n. Make sense? Okay? And how do you write a factorial, write a recursion to make sure it's correct? There are several things you have to know. One is that, firstly, you must have this thing. You must have a test here. This test will say that, do you want to go recursively or you don't want to go recursively anymore? So when n is equal to 1 or n is equal to 0, you stop. I said I don't want to go recursively because I know when n is equal to 1, factorial of 1 is 1. I have the answer. We call this a base case. Okay? And this one says that when n is not equal to 1, I assume n is greater than 1. I call n times factorial of n minus 1. Right? This is called the recursive case. Right? And you have the return here, right? You have a result, then you return here. Okay? So you have a test to say when should you stop doing recursively. And you have a recursive call here. And what it does is say you want to reduce the size of the arguments from n to n minus 1, n minus 2, n minus 3 until 1. Then you stop. All right, so there are two conditions, the test and the size get reduced recursively. Okay, so now I go to these things again. Right, recursive, I'm calling myself. What happens? So I have these things here, right? N has value 4, right? So I call factorial. Suppose the factorial 5 first. Here, n is equal to 5. No, sorry, it's 4. 4 or 5, whatever. So I'm calling myself. I'm calling myself. So what do? Do I do this? Call myself. I pass the thing to myself. Right? So if I pass the thing to myself, then myself have two values of n. One is 4, the other one is here, the value of 4 here. Maybe the value of here is 3, right? And then I call myself again. Now I have another value, which is 2. I call myself again. I have another value that's 1. Then what happened to my call, to my program? I'm going to die because there are so many values coming into myself. I don't know how to handle those things. Okay? So that's not how it works. Okay? That's how it actually works when you make a call to yourself. It's always the same thing. When you make a call, what do? You build another cursor. This cursor is exactly the same cursor as you have because you're calling yourself. Okay? This cursor will also have an n here. Okay? And now what I do is I pass this over. Right? Sorry, I shouldn't be writing here as n. This one is n minus 1. So this one should be n minus 1. Okay? I'm calling myself, so I pass the value over. Suppose this n, here n is equals to 5. So I call n minus 1 here, right? So n minus 1 is 4. So I pass n minus 1, which is 4, to another factorial function. This factorial function and the original factorial function are different cursor. They are not related. They are different cursor. Okay? So now this guy is very clean. I only have one n. This n is 4. Okay? And what do? I call factorial with n equals to n minus 1. n minus 1 is 3, right? So what do? I call another cursor and pass 3 over. Make sense? All right, so I keep building cursor and pass the value over. Every cursor is very clean. I only have one n. That's all. Whatever I receive, that's the n. And when the last cursor is what? N is equal to 1. It says that, when n equals 1, the result is 1. So it starts returning the result to the caller. And then here, n equals to 5. I'll wait for the result to come. And then what I do? I take the result of factorial of 4 and then times 5. Right? This is times 5. Then I get the result I return. Okay? So this is a very important concept, call stack. Make sense? Can I take a look at these things, archipelago again? Archipelago. What do you think is this result? Okay, I'm calling jump 2. Okay? And what I do is I call myself, n equals to 1 is return 1, n equals to 2, return 2. Otherwise, n is greater than 2. So I return n plus jump 2, n minus 2. What is the result? So I start with 4. What will be the result? Anybody? So you start with 4, right? 4 plus jump 2, n minus 2 is 2, right? Jump 2 of 2. 4 plus jump 2 of 2. Jump 2 of 2 is what? N equals to 2. So you return 2, right? N equals to 2, return 2. So you return 2 to jump to this thing. So this one, this is 4. This is 2. So jump 2 of 2 is 2. So 4 plus 2 is 6. So return 6. Make sense? Okay? Any question for this? I never opened the question. Sorry. Sorry. Thank you for telling me that. Okay, let me open another question. Simple one. How come the words are so big? Insufficient credential to retrieve question. Why? Okay, this question. This one doesn't require programming. Did I open it? I did not open. Did I open? I opened, right? What do you think is the answer? Okay. Are you sure? So many people say Bill Gates do something. Okay. So the answer, this one has no model answer, okay? The right answer is number 4. Stack Overflow basically means that you keep calling yourself recursively. Remember, every time you make a call, the caller is not returned yet. Caller call callee, callee becomes caller, you call callee, callee becomes caller, you call callee. You keep calling up, and then you use up the stack, and then the stack overflow. Okay, in Python, they'll tell you that maximum recursion step is seated in comparison. In other language, what they'll do is they'll say that the program crashed. Okay, the other thing is they may go into infinite loop, never stop. Okay, but stack overflow means that the stack, what is the stack? The call stack. The call stack, that is overflow. And why is it overflow? Because you keep calling yourself, never end. That's the reason. Okay? Make sense? The second answer that's correct is a popular website. There's a website called Stack Overflow. If you have a Python problem you don't know how to solve, go and Stack Overflow. They'll give you the answer. Right? Stack Overflow is a very popular website. They solve a lot of problems for you. Okay. Now let's go to a little bit more Fibonacci recursion. We look at a very important function called Fibonacci. Okay? This is a Fibonacci problem. It's called the rabbit mating problems. So rabbits are able to mate at the age of 1 month. Okay? And then after that, they get pregnant for 1 month. And after that, they produce in the second month, they produce a pair of rabbits. Okay? So the first month is here. The second month, they get pregnant. And third month, they produce something. End of second month, they produce something, a pair. Right? And the interesting thing is that these parents who get pregnant, they keep pregnant every month. Very productive. Okay? And this new pair, first month they just born, right? Not pregnant yet. Second month they get pregnant. And third month they produce a new pair. And then they get pregnant every month. They keep growing. So the question is that, and rabbit doesn't die. That's a beautiful part of it. Right? So the question is, how many pairs at the end of, let's say, 10 months, how many pairs of rabbits are there? Okay, this is called the Fibonacci problems. And this is the result that you can get. Okay, the first 0 month, end of 0 month, you have 1 pair. Then in the first month, end of first month, you have 1 pair. End of second month, you have 2 pairs. Then third month, you get 3 pairs, right? And then you have 5 pairs, you get 8 pairs. And then you keep growing. Okay? Fibonacci is used in many places. Okay, let me give you an example. This is an example that you can use Fibonacci to solve a more realistic problem. How many ways to arrange cars? Let's say we have two types of vehicles, the bus and cars, buses and cars, and each car can park into one parking space. A bus is bigger, can occupy two consecutive spaces. Okay, so bus uses more space. Right, that's the case. Okay, so if we have one parking space, how many cars can I park? One car, right? How many vehicles can I park? One. There's only one way. You can only park a car. If I have two spaces, how many vehicles can I park? There are two ways. One is either I park a bus. The other way is I park two cars, right? There's no other ways. Make sense? If I have three parking spaces, how many different ways can I park the car? Three ways, right? These are the three ways you can park the vehicles. Make sense? If I have four parking spaces, how many? 5 ways, right? You look at it, either you have a bus or you don't have a bus. If you don't have a bus, there's one way you park all the cars, right? If you have a bus, you can have one bus, then you can park in 3 different places. Or you can have 2 buses, then they have no cars. So 5 ways. Okay? And you have 5 parking spaces, you have 6 parking spaces, what will happen? Very hard to compute, right? It becomes harder to compute. Okay? And this is the result. This is the result. Then you get this answer. And what is this? It is Fibonacci. What is Fibonacci? This is a pattern. Right? If you look at the pattern here, what is the next number? When you have 7 parking spaces, what is the next number? Can you see the pattern? How do you get 2 here? 1 plus 1 is 2. How do you get 8 here? 3 plus 5 is 8. How do you get 13 here? 5 plus 8 is 13. Make sense? Okay? So in general, if I have n parking space, what do? If I have n parking space, what do? I find out how many space I need for n minus 2 parking space. I find out how many ways are there for n minus 1 parking space. I add them up. That's the number of ways I have for n parking space. Make sense? Okay, so this is how you reason it. Okay, suppose, I think of it, the last parking space can be either a bus or a car, right? I'm assuming n is big enough. Huh? The last parking space is either a car or a bus. If it's a car, I'm left with n minus 1 parking space. And I have a solution for n minus 1 parking space. I know how to solve it. Suppose I know how to solve it. Okay? If I park a bus at the end, I have n minus 2 parking space left for me to solve. Right? And for that, I have another answer for it. So that's the answer you have. Right? If it's a car, then there are n minus 1 parking left. Right? And then you have n minus, there's number of ways for n minus 1. And the same thing for n minus 2. So this is the answer. F means there is a function that tells you how many ways you can park the vehicles, given that there are n parking lots. And you say that the answer is what? When there are no parking lots, no answer, right? There's only one way. The one way is what? You cannot park the car. When there are 1 parking lot, 1 car, that's all. You cannot park a bus, right? And when there are more than 1 parking lot, what do? You find out if I occupy it using a car, I've left with n minus 1 parking space. How do I solve this? I call F again. If I park a bus, I've left with n minus 2 parking space. How many ways I can solve? Right? This is recursion. It's a very beautiful answer. Right? And this is the program. That's how you write the program. Fibonacci. If n is equal to 0, n equals to 1, you return 1. That's what it says here, right? N equals 0, n equals to 1, you return 1. Otherwise, you return, you call yourself Fibonacci n minus 1, Fibonacci n plus n minus 2, you add them up, and that's the answer. Okay? And then you can run it. This program is a Python program. You run it, you get the answer here. Fibonacci at 10 is 89. Fibonacci of 20, it grows very fast. Fibonacci of 994, what does it do? What does it do? Stack overflow. Stack overflow. I make so many calls, they never return. I use out my stack overflow. So this function it grows very fast. We say it grows very fast. You use up the space very fast because they have two calls there, two recursive calls there. Keep calling itself. Okay, so I make the number smaller. Fibonacci of 50. Try it. You'll find that it takes a long time to run. It's very slow. Okay. This is the answer for Fibonacci 2000. This is written in Python, a very simple program. Okay? You can write it using iteration. Don't use recursion, use iteration. You can get this answer. Try it out at home. Okay? I'm going to skip the archipelago. We'll talk about that later. Okay, I want to move to a new topic called variable scope. It's also a very important concept because some students have some problem with assignment 1 is related to this. Okay? Variable scope, what is a scope? The extent of the area or the subject matter that something deal with or to which it is relevant. So when you say a scope means a space. Right? In this space, I'm relevant to it. So I am within the scope. I am within the scope because I'm relevant to it. Okay? I becomes relevant. So we are talking about what is relevant? Variables. Is the variables, what is the scope of the variables? How is the variable used or can be used in a particular space? Okay? So there are two kinds of uses of variables. The first kind is called use. Okay? The first kind is called use. So here, use means this thing. Use means you can access the variable. Access means what? You read out what is the value of the variables. Or you can read the variables, you can reference the variable, you can access the variable. All these are called use. The word is use. So when you use it, this is the use. When I look at this statement here, 360 divided by n. I'm using n. I want to know what is the value of n. So that's a use. Make sense? I look at this statement here. I want to times radius. I'm using the value of radius. So I'm using it. Make sense? Okay? So these are the use. So you look at there, how many variables are being used in this program or in this function? By the way, this is just a comment. Don't have to read this part. The program is here. Right? Program is here. How many variables? How many variables are used here? 1. Right? Anchor is used here. It's a variable. Radius is used here. Radian is used here. Use means I'm reading the value. Right? I need to read the value in order to do computation. Polysize is used here because I'm going to take the value and return. These are used. Okay? We only talk about variables. We don't talk about function. This is a function. We don't talk about that. We don't talk about this. This is pi. Pi to me is a constant. Pi is a constant. It's not a variable. You don't want to change it. Okay? So how many use are there? How many variables are used? N, anchor, radian, radius, polysize. 5 of them. Right? Every one of them, how many times do you use it? Every one of them, how many times do you use it? 1 time, right? Correct or not? You look at the whole program, you never use n second time. Right? Agree? Only 1 time. So the maximum number of use of the variable here is only 1 time, no matter which variable you choose. Okay? Next one. Second idea. It's called def. Def means you define something. Def means you want to update something. Def means you want to assign value to these things. That means you are not using it, but you are putting value into it. That's called def. Okay? Or called define, or called update, or called assignment. You assign a value to this variable. So we call this is a definition or the def of a variables. Okay? So look at it. Here I'm defining, here. I get a value of 360 divided by n. I assign it to angle. So I'm defining the angle here. I define what is the value of angle. Make sense? Similarly, I define what's the value for radian. I define what's the value for polycyte. Right? So all these depths are always on the left-hand side of the equation, of the equal of the assignment. Make sense? So that is depth. Use is always on the right-hand side of the assignment. Okay? Radius. When you create this function, you say there are two variables I want to use. One is n, one is radius. So at this time, you are defining two variables. So that is depth. Make sense? So you can see that a radius is defined here is, oh dear, it's here. It's used here. Radius is supposed to be here. This way is supposed to be here. Right? A radius in this program, radius is defined here and used here. N is defined here and used here. Make sense? And the scope basically means that when I look at a variable, I want to know where is it defined, where is it used. That is called the scope. A function that is a variable that is defined, it can only be used in certain place. So for example, n. When I define n here, where can I use n? In this function. Sorry. Outside the function, I cannot use n. I cannot use this n. Right? Radius, I define the radius here. I use this function. Outside the function, I cannot use radius. Or at least when I see the radius, it's not this radius. This radius, which is defined here, is only used within the function. Does it make sense? This angle, which is defined here in this function, can it be used outside? No. It can only use in this function. So the scope of this angle, this variable angle, is within here. In fact, it's even smaller. The scope is just here. When you define here, you can only use angle here, in this place. Angle 1 is defined here, you can only use in this place. Okay? And this is so ugly now. How do I clean it? Right? And I've defined n here. N can be used in the whole place. Every place I can use n. Of course, I can redefine n. I can even write here, n is equal to n minus 1. Then this n is use of this definition. And this n is use of this definition. Agree? Okay? So there's two ideas. Use, define. You define what is the scope. Okay, let's look at this one. How many distinct variables are defined here? Distinct variables are defined here. N, radius, angle, radian, polycyte. 1, 2, 3, 4, 5. 5 variables are defined in this scope. And they are used in this place. They cannot use outside this function. Right? Remember, a function is a cursor. In this cursor, they build a lot of things inside. They define a lot of things inside. Those things will be kept inside the cursor. You cannot bring it out. Okay? Unless you pass a function out. Even pass, when you call a function, pass it out, you can only pass by value. You don't pass this variable over. Make sense? Cursor. Remember the cursor. Okay? Any variables in this program that is defined but not used? It's not a variable that is defined here but not used. Any? I can check, right? I define n here. Is it used? In line number 2, in line number 4, right? Number 4 is used. Line number 5 also used. I define r here. Is it used? Line number 2, number 3, number 4, number 5, all used. I define m here. Is it used? Yes, where? Where? Line number 5. Do you use m in line number 5? Do you use n in line number 5? You don't use. you define a new m, right? So where is m used? Never, right? This m is never used. You define it, you never use it. Right? You redefine it here. And then you use it here, right? So what does it mean? This line is redundant. You can throw this line away, the program still runs. No problem. Make sense? Okay? Any variable used but not defined. Is there a variable that is used here but not defined? Okay, let's one by one. Huh? Where is sum used? Sum is used here. Is it defined? Where is it defined? It's either here or here, right? Make sense or not? Let's look at it later on. This sum, is it used somewhere? Is it used? It's look, I'm redefining here, right? Is it used? Is the sum used? Yes. Can you see that it's used? Why is it used? There are two cases. One is this. Right? This one is this one, right? Sum is here. Where do you get the sum? Here, right? Correct? Correct? You get the sum from here. Sometimes from here, sometimes from here, because this is the loop. Okay? This sum, where do you get it from? It can get from here, right? Correct? This sum can be getting from here because you go to the loop. When the loop comes out, the sum, the value of sum is here. Where else? It also comes from here. Why? Because when the input is not equal to, is not greater than 0, it doesn't go into the loop. It does not go into the while loop. When the test is false, it doesn't go into while loop, right? So it gets out, and then it returns sum. So sum will be 0. Make sense? Okay. So this is used. It's defined and it's used. Any variable else that is defined and not used? Any variables that's used but not defined? IMP. Okay, let's look at IMP. IMP here. Is it, this is used, right? Is it defined? Is it defined? No. It's partially defined, right? Because when you go into this loop, you have this IMP here that's defined, and then this IMP will come out here again, right? When you go to the loop. So this IMP can affect this one. Correct? But the first time when you come in, when the first time you go into this loop, before you go into this loop, you check whether IMP is greater than 0 or not. What is IMP then? Not defined, right? Correct? IMP is not defined. So what happened to this program? Error. Right? Python will say that you cannot run this program because IMP is not defined. Does it make sense? Okay? So when a variable is used but not defined, it's dangerous. It's very dangerous. Okay, give me another 5 minutes to finish it. Huh? Sorry. This is a program that, if you look at this program, I'm defining a print x. What I do is I call random, right? So I go through a range from 0 to n, right? So 0, 1, 2, 3, up to n minus 1. And I take the value of those things. And what it does is that I have this random here. Every time I go, I pick up a random number between 101 and 303. Okay? And I put the value into x, and then I print out x, right? So in this program, this is fine, right? So x, you print out the x. So when you call this print x with 2, right? N is 2, so you run 2 times, so you print out 2 values. And now when I ask, after you do all these things, I ask what is the value of x. He said, I don't have a value of x. Why? Because this x is only defined within print. When you're outside the print x, variable is unknown. Okay? Remember, when you're in this thing, what is this thing? This is your console. This is your console. Console is a new cursor, it's its own cursor. It has its own region. When you call a function, that function builds a cursor inside, right? And that cursor has an X inside. This console doesn't have an X inside. So I don't know why it's X. Make sense? That's an important concept. And the other thing you have to take a look is, interesting thing is that there's a variable here that is used, that is defined but not used. There's a variable here that is defined but not used. It's I. You keep defining I, you never use I. Make sense? Think about that. Huh? You define I, you never use I. Okay, summarize it. The scope of a variable x is within the definition of the function. It is called the local variables. This x is local to print x. It's local to print x, right? It lives in print x. It is not accessible outside print x. Okay, so when you write in this way, you say x is equal to 10, and then you call print x. X has new value 299166, right? But those x, the value of x are obtained from this cursor. This is the cursor that have the x there, and you print out the value of x there. When you get out of the cursor, x still 10. There's no change for x. Okay, similar for these things, right? A bit this difference. Okay, look at this one. Look at this program. So I define this program. I say print x plus 1. Is x used? X is used here. Is x defined? Is x defined inside this function? It's not defined. So the system automatically go to the mother to get the value for x. So in this case, you get the value of 17 and put it here. So this is print 17 plus 1, you get 18. Okay, makes sense? And then what is the value of x? Well, x is used 17, you never change x. Okay? So this, although this is a thing, so there is something called global variables in which you can access. If you cannot find within your cursor, you go and ask the mother, the bigger one, that enclose you, and say, do you have a variable there for me? Okay? Let's look at this one again. Okay? Look at this one. I have this function here. In this function, I have an x here. Then I have x equals x plus 1. Okay? And then I print out x. When I try to run it, they tell me there's an error. Why is there error? Let's look at it. Unbound local variables. Local error. Local variable x reference before assignment. Okay? And it says it's 92 at this place. At this place, you want to find what's the value for x. But you cannot go to the mother. Go to the mother to find what is the value of x. Why? Why you cannot? Because in this program, you have defined the x. You have defined the x inside. And therefore, because you have defined the x, they will assume that x has to be local, cannot be global. If x has to be local, cannot be global. That's the reason. Because you define x inside the function, so x is local to this function. And therefore, you cannot get a value from the global. So in this case, they tell you that, hey, you define x, but you use the x before you define. You use the value of x before you define. That's wrong. You should define, then you use. Make sense? Okay? So that's a rule of variable which is defined in the main body. It's called a global variable. It is visible throughout the whole files or console, right? Except what? A variable is defined inside a function is local to the function. When you define a function, inside a function is local, right? It is accessible from the point at which it is defined until the end of the function. So you look at this one here. I define a function here. I define here. It is used here. It is not used above. It's not used above. Right? And therefore, those variable x above are used but not defined. They are problematic. Okay? Question for this? How do I make sure that I can use global variables? I do these things. So I want to this print x. And this print x, I want to use this x. I want to use a global x. Okay? So I tell the system, x is global. So in this case, when you do this thing, It knows that what you are trying to change is the global X. Is the global X. So this program will be fine because you have declared that X is global. Okay? Global variables are very bad practice. Don't do it. Okay? 99% of the time, you only use global variable as a constant. You don't change it. So global variables, just don't use it because it creates a lot of problems in your program. Very hard to debug your program. Okay? Try not to use it. Okay? So this is the case in which I use this thing. I use this thing here. Right? This is a function. I use this thing here. This is a function. I use this thing here. They are written as uppercase. This is a way to practice to write. If you want to write a constant, you use uppercase to write it. So when you see an uppercase, you know this is a constant. Although you can change it, but you know that it's a constant. Practice it like a constant. Okay, so I want to stop now. So we cover parameters, return values. Sorry, there are a lot of things to cover here. I hope you can digest it. And next week we'll go to recursion again. Hope you like it more. Thank you.
General rule, right? Can I just basically break down recursion to